Okay, all right. Today we're going to be talking about prime numbers. Well, first of all, we'll look at the definition of prime, what it means to be a prime number. Then we'll look at a few prime numbers and then look at a few things you have to remember about prime numbers. Okay, first of all, we'll start with the definition. Okay, a number is considered to be prime if it has only two factors. Okay, a prime number has, I said only, but I'm going to write exactly because I think that's even better. Exactly two factors. Okay, and them two factors will always be 1 and itself. So I'll put comma 1 and itself. Okay, so we'll look at the numbers from 1 to 10. Okay, we'll decide whether they're prime or not, and then I'll list them up to 50 and I'll tell you some other important things to remember. Okay, so we'll write our numbers from 1, 2, 3, 4, 5, 6, 7, 8. Tell you what, we'll just go up to 9. We'll soon be clear why we're not bothering with 10. Okay, so the definition of a prime number is it has exactly two factors, 1 in itself. If you look back at our video last time, what we mean by factors are whole numbers that times together to give that number. Okay, so let's start with 1. So if we're to list the factors of 1, well, 1, the only way you can get 1 by timesing two whole numbers together is by doing 1 times 1. Okay, so if I was to list the factors of 1, in fact, I'm going to do a factors column, a row. That means there would just be one factor of 1, which is 1. Okay, remember, a prime number has exactly two factors. Okay, so this is not prime. Let's do a little cross through it. Okay, 1 is not prime. Next number, 2. The factors of 2 are, well, the only way you can get 2 by timesing two numbers together is to do 1 multiplied by 2. So that means the factors of 2 are 1 and 2. You have exactly two factors, which means this is prime. Let's have a look at 3. So the only way of getting 3 is if you do 1 times 3. Okay, that gives us the factors of 1 and 3. We have exactly two factors, so it must be prime. So we've got two prime numbers next to each other. That's interesting. Right. 4. 4. We can get 4 by doing 1 times 4. 4 is also a square number, so we can get it from 2 times 2. So the factors of 4 are 1, 2, and 4. So we've got 3 factors. That's too many, so it's not prime. Let's do a cross through 4. Numbers that can multiply to give us 5. Well, the only two numbers that multiply to give us 5 is 1 and 5. So that means that has factors of 1 and 5, so 5 is prime. 6. Well, 6 is the same as 1 times 6. We can also do 2 times 3. So that means the factors are 1, 2, 3, and 6. Should get my commas in there because it's a list. Okay, that means that is not prime. So let's do our cross through that. Okay, I'm just going to highlight something quickly. So hopefully we can see a problem arising here. I'm going to highlight these 2's. Okay, whenever we have an even number, it has a factor of 2. That's the definition of an even number, okay? So that means, without even listing our factors, I know that 8 is not a prime number, okay? And I didn't write 10, but I know because it's even, it's not a prime number, okay? In fact, the only even number that is prime is 2. That is one of our facts we need to remember. The only even number that is prime is 2. Cool, so let's carry on with these last couple. We've got 7. The only way of getting 7 is 1 times 7. So 7 is prime. And then we won't bother with 8 because we know already that that's not going to be prime. 9, you can get by doing 1 times 9. Also, it's a square number, it's 3 times 3. Okay, that means our factors are 1, 3, and 9. So that is not prime. Okay, so between 0 and 10, our prime numbers are 2, 3, 5, and 7. Okay, so remember 1 is not a prime number because it has one factor. A prime number has to have 2. 2 and 3 are both prime. Then 4 is a square number, so that means by its nature there's something else that it has another factor, which is 2, so it's not prime. From 4 onwards, we know all the even numbers are not prime, okay, because 2 will always be a factor. 5 has only factors of 1 and 5. 6 is even, so we know it's not prime. 7 has only got 1 and 7. And then 8 has a factor of 2 and 9 has a factor of 3. Right, okay, I'm going to quickly list the factors up to 50. A lot of these you can work out by using our divisibility facts. And then I'll talk through a couple that are good to remember because they don't... they kind of look like they might be prime, but they're not, okay? So let's go. We'll do the first ones to begin with. We have between 1 and 10. Let's do, we'll write these. Prime numbers to 50 is what we're going to do. Okay, prime numbers to 50. Here we go. So our first ones are 2, then 3, then 5, then 7. Okay, our next prime number after that is 11, then is 13, then it is 17, then it is 19, then it is 23, then it's 29, then it's 31, then it's 37, 41, and 43, and then finally 47. Okay, there's not a lot of patterns in here. Okay, you'll see apart from 2, they're all odd. A lot of the times they're very close to a multiple of 6. For instance, these both are either side of 12. Okay, these both are either side of 18. This is very close to 20. 24. So they're all often very, very close to multiples of 6, but because a number is close to a multiple of 6 does not necessarily mean it's prime. Okay, so there's 2 other numbers I think are important to remember. Reason being they look like they might be prime, but they're not. Okay, so the first number is 51. Okay, at a glance that looks like it could be prime. Okay, but when we do our divisibility tests, which is something useful to know when you're testing to see if something is prime or not, you can check to see this. Well, it's obviously not divisible by 2 because it's not even. Is it divisible by 3? Remember to work that out. We do 5 plus 1 is 6. 6 is in the 3 times table, so this must be divisible by 3. Okay, 51 is in fact 3 lots of 17. Okay, so you'll notice these numbers are harder to spot when you're timesing 2 prime numbers that are quite big together. Okay, the other number that is not prime but looks like it is 91. Now this does not pass our divisibility test for 3 times table. Okay, in fact, all the easy divisibility tests don't really work on 91. Okay, the reason is because it's in the 7 times table. Okay, 91 is equal to 7 times 13. Okay, so these are kind of the 2 tricky ones. I think a lot of the other ones kind of, you can use a divisibility test to check. I mean, this one you can, it just looks like it might not be. And as I said, there's not really a pattern. The best thing to do is to take your number, do your divisibility test, see if they're divisible by them. Yeah, if in doubt, try your 7s. Remember, bus stop method.